841. I got to be honest with you. I actually really, really like this lesson. I don't know if you guys will. I hope you do. But we're going to look at something with infinitely many sides. And what does that mean to have infinitely many sides? So first, we would break this up into groups in class. So I'm give like one group a triangle, one an octagon, one a 30gon, whatever, until we ran out of groups, and then we would compare the answer. There's no way I'm going to do what it asked me to do here for all these shapes. I'll do it for a couple of them, but that is all I will do. So it says predict the area and the perimeter of a polygon with infinitely many sides. Your team is going to work with other teams to generate data from different polygons and then look for a pattern. So we're going to, it says for each polygon you are assigned, calculate the area of the perimeter with a radius of 1 as shown. And again, a radius means it goes from the middle to one of the vertices. An apothem, you'll recall, goes to the middle and makes a 90-degree angle. We do not want an apothem. We do want a radius. And it says to be as accurate as you can, so we will keep that in mind as we go. We want a nice disbursement of numbers here, so I just done notes to do specific ones, and then I think what I'm going to do is sort of ignore the ones that I chose and pick something that disperses them a little bit better. So why don't we do a square, a decagon, and a 30gon. So we'll do a square, a decagon, and a 30gon, and then I'll just go to the answers and you can look at the rest of these things. So I was going to do a square, decagon, and a 30gon. All right, so if I have a square with a radius of 1, I know that this is also a radius of 1. I know that I can divide 360 by 4 and get 90 degrees. So I hope you guys recall all this from section 8.2. 1, I believe, A21 and A22, we did these. Okay, so at this, we have something that looks like this. I can kind of set this thing up over to the side. I'm just taking this little chunk over here. And again, what I'm looking for is the perimeter and the area. So this is going to be, I guess, I probably shouldn't do it that way. So let's do it this way. We're going to say the shape. We'll do the perimeter, and we'll do the area. So on this one, my shape is a square. It's four-sided. I'm going to get my perimeter. Well, I know that 1 squared plus 1 squared is the square root of 2. So this is the square root of 2. Obviously, this is square root of 2, square root of 2, square root of 2. So I'm going to grab my calculator, and I'm going to get 4 times the square root of 2, and I'm going to get 5.66. And again, I'm rounding on these. So 5.66 is going to be my perimeter on a square. To get my area, again, it's half of base times height. And don't forget that we're looking at the whole thing here, right? So half of 1 is half times 1 is a half. So the area here is a half, another half, another half, another half. So 0.5 times 4 gives me an area of 2. I hope we are all in agreement on that. And we will move forward and we will do the decagon. And I gotta be honest with you, I'm not really gonna try. Why is my life so hard? Okay, I'll just leave that there, and then hopefully that won't make me lose my white thing, the whole white triangle. So a decagon, I don't know. It's obviously 10 sides. You're gonna see that I can't really draw these. I don't really care, but what I will do is I'll draw the internal triangle that goes with it. Again, first of all, we know that we have a radius of 1, so it's going to look like that. And then if we have a central angle, it's going to be 360 divided by 10. Hopefully you remember that. So it's going to be 36 degrees. So when I break this thing in half, I'm going to get a little triangle that looks like this in 18 degrees. Now I'm going to need the base and the height. So I'll call this the opposite and the adjacent. Again, reviewing a little bit of trig here. So I'm going to say the sine of 18 degrees, and it's going to be super easy here, is going to be O over 1. So literally it's just going to be whatever the sine of 18 degrees is, because then I'm going to multiply by 1 and it won't change. So the sine of 18 is 0.3090. So I know that this is 0.3090. And now I want the cosine of 18 degrees. So the cosine of 18 again is going to be a over 1. And again, it's just whatever the ratio is. So the cosine of 18 is going to be 0.9510. So if I want to get the area of this, it's going to be half of base. Well, again, keep in mind, this is already the half right here, right? So if I go 0.3090 times 0.9510, I will have used half the base times the height. I'll have the area of this whole triangle right here. So I'm going to do that, 0.9510. I'm going to leave the numbers in the calculator. I'm not going by 0.3090. I'm going by 0.3090, 1699944, etc. So this area of this triangle is going to be 0.29389. Got another phone call. I'm going to multiply this by the 10 triangles in a decagon, and it's going to end up being 2.93. I'm going to round to 2.94. So my area is going to be 2.94 for a decagon. Again, 10 sides. And sorry, this is so sloppy. Now I need to get my perimeter. Well, again, I know my perimeter here is 0.3090. 0.3090. Well, think about it. If I double that, I'll have one side of a decagon. So 0.30. And again, I'm going to use, they told us to be like specific. So I'm going to go 0.3090169944. I'm going to multiply that by 2. That gives me one side of a decagon. So that's 0.618033. Then I'm going to multiply that by 10 because it just keeps going. So I'm going to end up at 6.18. Hopefully that makes sense. Again, sorry I can't draw these shapes. I hope you understand what I'm saying. Again, if you followed 831 and 832, you know what I'm doing. If you didn't, you don't, and you should go back and watch them. Again, that's the problem with math, is it always sort of adds on to itself. So, oh, jeez. Leaving that little thing there didn't really help very much. Maybe I'll leave that as well. I'll just leave that little O right there. I don't want to lose the whole... well, that's working great for me. So I will go ahead and give up and draw a new white square to use. Okay, now I want to use a 30gon. And on the 30gon, again, I'm not going to be able to draw a 30gon. I'm just not going to be good at it. So it's got a bunch of shapes, and I just want to look at one little triangle of it. So I know that 360 divided by 30 is 12. So my central angle is going to be 12, right? And I know my radius is 1, and I'm going to cut that in half. So I'm going to end up with something that looks like this. 6 degrees here, 1 here. And again, I want to know the opposite and I want to know the adjacent. So I'm going to say the sine of 6 degrees is equal to O over 1, and the cosine of 6 degrees is equal to A over 1. I'll grab my calculator. Again, I'm in degree mode, so the sine of 6 is 0, actually I guess already here, 0.1045. And the cosine of 6 is going to be 0.9945. Again, if I want the area, I know that I have this half of base. This is 0.10405 is half of this whole thing, and I'll just multiply it by the height, and that will give me the area of one of the 30 chunks. So I will multiply that, 0.10452844633, and I get an area here for this triangle of 0.103 9, 5, 5, 8, 4, 5, 4. Again, I have 30 of those, so I'll multiply it by 30, and I get an area of my 30gon. I get an area of 3.12. Now I'm going to go back and figure out my perimeter. Well, I have 0.1045, right? So I'm going to take that 0.1045, and I'm going to multiply it by 2. That's going to give me this whole chunk. And again, I have 30 more chunks, so I'll multiply that by 30, and I get 6.27. At this point, I'm going to be done now. I'm not going to keep going on this. You could have got 100-sided. You could have got a whatever. But you begin to see this chart here. And what I want to do is kind of jump ahead a little bit and show you where we would have ended up with this. So we would have ended up with this chart. 3 gives you this area, this perimeter. We did 4, we did 10, and we did 30. I think the numbers are pretty accurate. Hopefully you agree. I don't really remember. But look what happens when we get to 60. Look what happens when we get to 90. Look what happens when we get to 100. We begin to sort of, it turns into the same thing, which is kind of weird, unless you already sort of recognize what's happening here, which is, again, I think pretty cool. So let's see here. I want to erase all this stuff. Now watch, I want to get rid of the white square, and this will be the one time that the white square doesn't actually go away. Hey, it went away. All right, so now it's asking us to sort of analyze our data. So with your team, analyze the data you collected by your class. What do you predict the area will be for a polygon with infinitely many sides? Well, again, if we jump back over here, it looks like it doesn't matter what happens after even about 30. It just stays 3.14 and 6.28. So I guess that if it has infinitely many sides, I would expect the area to be 3.14. And the perimeter would be 6.28, right? It seems logical based on what we just witnessed. What shape does a regular polygon with infinite many sides resemble? And, there's cool videos that you can watch on YouTube of people doing this. They start with the square and a table saw, and they cut, and they cut, and they cut, and they cut, and they just keep cutting it down. And I'm not going to do a great job of this, but I hope that you begin to see a particular shape emerge the more you start to do this. It starts to circle out, right? Weird that I have yet to draw a curved line at all, but you can see it's starting to turn into a circle. So it's interesting. That's what a circle is. A circle is infinite sides polygon. So does number 3.14 look familiar? Yeah, I think it's pi. 3.14, whatever. So pretty interesting stuff. Like I said, I really like this chapter. Hopefully you guys are okay with it so far if you're following along. I will discard that. I will reopen this. And I will go to part B. Okay, so it says area and circumference of a circle. Now that you know the area and circumference of perimeter of a circle with a radius of 1, how can you determine the area and circumference of a circle with any radius? Explore the tools, the Desmos below, and answer these questions. All it is 2 circles. It kind of doesn't really show up the way I would like it to, so that's okay. I'll show you kind of what it is. Actually, you know what? I can probably go here and show you what it is so we can see it. That it's really not that big of a deal. It's just a circle with a radius of 1 and a circle with a radius of 3. And it says, what's the relationship? Well, all circles are similar because they all have the same shape, right? They can be different sizes, but essentially they all have the same shape. So they're all similar. So again, this is kind of what's shown over here. So it doesn't really matter that we don't see it because we can see it here. Now, it says refer to the circles, right? What's the ratio of the perimeters? Well, the perimeters, it looks like it's 3 times bigger. So we would say the perimeter is 3 times bigger, but the area, well, it looks like it's 3 times 3. It looks like it's going to be 9 times bigger. I hope we're all in agreement there on the perimeter and the area. So again, the perimeter's 3 times bigger, but the area is 9 times bigger. So if the area of a circle with a radius of 1 is pi square units. What is the area of a circle with a radius of 9? Well, hopefully we know this already, and if we don't, the area of a circle, that's what this whole lesson is basically getting us to see, that the area of a circle is pi r squared. And that's why, right? It's kind of interesting. We have that 3 times 3, so we'll get 9. So in this one, I guess it would be 9 pi if it had a radius of 3 units. What if it had 10 units? Well, I guess it would be 10 squared pi, or it would be 100 pi. And likewise, what's the circumference? If we know that it's, again, I hope we know that the circumference of a circle is 2 pi r. But if you didn't, that's what we just figured out with this. And I'll go back and I'll show it in a minute, but that's what we just calculated. So if I look at a radius of 3, well, if the radius is 3, that tells me 3 times 2, I get 6 pi. And you can multiply pi of like 3.14 or whatever, or you can leave it, it's fine. What if it's 7? Well, if it's 7, it's going to be 2 times 7, we'll get 14 pi. And again, I want to jump back over here. Remember what we talked about, this 2 pi r and this pi r squared.